Good evening, student. Yes. So let us continue the session. Yesterday we were discussing about matrix, plural form matrices, order of matrix, then number of entries in a matrix, general form of representation of a matrix, and construction of a 2 by 2 matrix or 3 by 4 matrix, whatever it be, construction when the particular entry is given. Then we started with the types of matrices. We were discussing different types of matrices. Let me just recall the one which I completed in the previous session. First one, row matrix. Matrix consisting of single row is called row matrix. Column matrix. Matrix consisting of single column is called column matrix. Next, rectangular matrix. Even this we discussed. Rectangular matrix is nothing but matrix in which number of rows and number of columns are unequal. Matrix with the different number of rows and columns. Yes. Null matrix or zero matrix. Even this we had discussed yesterday. Matrix in which each and every entries are zero is called zero matrix or null matrix. Hope the screen is clear. Hope it's clearly visible. ಕಾಣ್ತದಲ್ಲ ಸ್ಕ್ರೀನು? ಏನಾದ್ರೂ ಇದ್ರೆ ಮೆಸೇಜ್ ಮಾಡಿ. ಒಮ್ಮೆ ನಿಮ್ಮ ನೆಟ್ವರ್ಕ್ ಚೆಕ್ ಮಾಡಿ. Yes. Then even square matrix we had discussed yesterday itself. Square matrix is a matrix consisting of equal number of rows and columns. See, if I consider this particular example, there are 2 rows and 2 columns. Hence, order of the matrix 2 by 2, which is a square matrix. Next, identity matrix, let me discuss later. Yes. Then we were discussing about diagonal matrix, before which I'll consider a square matrix. ಒಮ್ಮೆ ನಿಮ್ಮ ನೆಟ್ವರ್ಕ್ ಚೆಕ್ ಮಾಡಿ. ಕ್ಲಿಯರ್ ಉಂಟು, ಆಕ್ಚುಲಿ ಸ್ಕ್ರೀನ್ ಕ್ಲಿಯರ್ ಉಂಟು. ಒಂದು ಸಲ ನೆಟ್ವರ್ಕ್ ಚೆಕ್ ಮಾಡಿ. Yes. Square matrix. A, B, C, D. Matrix with 2 rows and 2 columns, in which entry from left to top to right to bottom is called principal diagonal. Elements from left to top to right to bottom. And the elements are known as diagonal elements. Now, yes, very good. Now let me consider diagonal matrix. A diagonal matrix is a square matrix in which non-diagonal entries are zero. See, diagonal entries in the sense elements from left to top to right to bottom. I'll consider a square matrix of order 3. 1, 3, -5. Let it be the diagonal entries. Non-diagonal entries are 0. Example for diagonal matrix. Thus, a diagonal matrix is a square matrix in which non-diagonal elements are 0. Diagonal elements can be anything, but all diagonal elements are 0 tekolbedi. In that case, it reduces to a 0 matrix. Clear, no? Yes. Next, special type of diagonal, nothing but scalar matrix. A scalar matrix is a diagonal matrix in which the next one, Scalar matrix is a diagonal matrix in which all the diagonal entries are equal. I'll consider the diagonal entries as 2, 0 on the non-diagonal. This is a scalar matrix of order 3 by 3. If I consider of order 2, say -3, 0, 0, half, which is actually a diagonal matrix. If I consider equal diagonal entries, -3 and -3, it reduces to a scalar matrix. Thus, a scalar matrix is the diagonal matrix in which diagonal entries are equal. So, I'll consider this for time being right now as -3. Now, the scalar matrix. So, scalar is a special type of diagonal matrix. Clear now? Next. Identity matrix. Identity matrix. Identity matrix, again, a special type of scalar matrix in which diagonal entries are 1. Clear now? Identity matrix is a scalar matrix in which diagonal entries are 1. Diagonal matrix, so non-diagonal are 0. Clear now? If I consider of order 3, diagonal entries are equal to 1. Non-diagonal entries are 0. Diagonal matrix in which all diagonal entries are equal to 1. Or scalar matrix in which the constant is equal to 1. Clear no? Thus, identity matrix is a scalar matrix in which all the diagonal entries are equal to 1. Now, what is the difference? Already I had mentioned about the scalar and diagonal matrix. All these scalar, diagonal, identity are square matrices. Square matrix in which non-diagonal entries are 0 is called a diagonal matrix. A diagonal matrix in which all the diagonal entries are equal is called scalar matrix. A scalar matrix or a diagonal matrix in which all diagonal entries are equal to 1 is called identity matrix. ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ ಇದು ಡಿಫರೆನ್ಸ್ ಗೊತ್ತಾಯ್ತಲ್ಲ? ಕ್ಲಿಯರ್ ನೋ? ಎಸ್. ನೆಕ್ಸ್ಟ್ ಸಿಂಗ್ಯುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈಗ ಅಗತ್ಯ ಇಲ್ಲ, ಅದು ಆಕ್ಚುಲಿ ಡಿಟರ್ಮಿನೆಂಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಬರೋದು. ಬಟ್ ಸ್ಟಿಲ್ ಲೆಟ್ ಮಿ ಮೆನ್ಷನ್ singular matrix is a square matrix in which determinant of the matrix is equal to 0. But determinant concept ಬರೋದು next chapter ಅಲ್ಲಿ. So for time being, you ignore determinant or singular matrix. Next, if I want to compare two matrices. If I want to compare two matrices, say two matrices A and B. Two matrices A and B are said to be equal if they are of same order. Order of A should be is equal to order of B. And corresponding entries, I'll consider ijth entry of matrix A as Aij, ijth entry of the matrix B as Bij. The corresponding entries are equal. Two matrices are said to be equal if first condition, order of A equal to order of B. Second condition, general entry, say ijth entry of A should be equal to ijth entry of B. Next. Now, example. Let A is equal to 1, 2, 3, 4. B is equal to matrix 1, 2, 3, 4. Order of A equal to 2 by 2. Order of B equal to 2 by 2. A and B are equal matrices. Clear now? What about the entry? First entry A11 is 1. B11 is also 1. First entry of A is equal to first row, first column entry of B. 1, 2, 3 entry, first row, second column of B is equal to first row, second column entry of the other. So, compare everything. Clearly, you can say matrix A equal to matrix B. Matrix A equal to matrix B. ಗೊತ್ತಾಯ್ತಲ್ಲ? Two matrices are said to be equal if order of A equal to order of B. Corresponding entry of A is equal to corresponding entry of B. Next, now I'll move to operations on matrices. Very important, different operations on matrices. First, I'll consider addition of two matrices. Addition of matrices. Let me explain in detail. Very important. Two matrices can be added if first condition order of A equal to order of B. Only in that case I can add two matrices. If order of A equal to order of B, I can add, and the sum of two matrices is a matrix obtained by considering the sum of corresponding entries of A and B. Add ijth entry of A and B, add them, that gives you the sum of matrices A and B. Here, to find the sum, first condition, order of A equal to order of B. Second, the elements of the sum obtained by adding corresponding entries of A and B. If, example, first matrix 1, 2, 3, 4, 0, 5. I am going to add with 0, 1, 7, 2, 3, minus 1. Order of the first matrix, there are 2 rows, 3 columns. Order of the second matrix, 2 by 3. So I can add the matrices. Sum is obtained by adding corresponding entries of A and B. First entry of the first matrix is 1, whereas the second is 0. Next entry, 2 from the first, 1 from the second. Add them. Next entry, 3 from the first and 7 from the next. That's the first. Next, 4 from the first, 2 from the second. 0 from the first matrix, corresponding entry from the second is 3. 5 from the first and minus 1 from the second. Add them. 1, 2 plus 1 is 3. 3 plus 7 is 10. 4 plus 2 is 6. 3, 5 minus 1, 4. This is how you need to find the sum of matrices. Two matrices can be added if they are of same order. To add, identify corresponding entries of first and second. Add the corresponding entries. That's the method. Clear? Consider ijth entry of first, ijth entry of second. Add them. One more example if needed. One more example. Matrix A is equal to sin square x, cos square x. Matrix B is equal to cos square x minus sin square x. Clear? A is of order 2 by 1, 2 rows, single column. B is also of order 2 by 1. If I want to add them, the sum A and B, both are of same order, so I can add them, obtained by adding corresponding entries of the matrices. First entry sin square x. From the second, it is cos square x. Next row, from the first matrix, it is cos square x. From the second matrix, it's minus sin square x. Add. We have from trigonometric identity, sin square x plus cos square x is equal to 1. Cos square x minus sin square x, cos 2x. ಗೊತ್ತಾಯ್ತಾ? Yes. To find the sum, identify corresponding entries and add them. ಫಸ್ಟ್ ನೀವು ಆರ್ಡರ್ ಸೇಮ್ ಇದೆಯಾ ಅಂತ ನೋಡ್ಬೇಕು. ಎರಡು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇದು ಆರ್ಡರ್ ಸೇಮ್ ಇದ್ರೆ ಮಾತ್ರ ಆಡ್ ಮಾಡಬಹುದು. To add, identify sum of corresponding entries of the matrices. Yeah. Next. ಈಗ ನಾನು ಇಲ್ಲಿ a plus b ಮಾಡಿದ್ದು. What if I need to find b plus a? b plus a ಮಾಡಬೇಕಿದ್ರೆ ಫಸ್ಟ್ 0, 0 plus 1. Next 1 plus 2. ಯಾವುದೇ ಆರ್ಡರ್ ಇರಲಿ. Since I am adding real numbers, real number holds addition property. What are the properties? Commutative property. So I can say, in the case of addition, a plus b is equal to b plus a. While adding matrices, commutative property holds good. ಈಗ ಬೇರೆ ಬೇರೆ ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನು ನೋಡುವ ಮತ್ತೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವ. A and B are of matrices of order 2 by m by n. Then I can add them if they are of same order. And I can find the general entry by identifying the sum of corresponding entries. ಗೊತ್ತಾಯ್ತಾ? ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್, ಈಗ ನಾನು A ಒಟ್ಟಿಗೆ A ಅನ್ನೇ ಆಡ್ ಮಾಡಿದ್ರೆ, add the corresponding entries. A ಒಟ್ಟಿಗೆ 0 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ, remains the matrix A itself. A ಯ ಒಟ್ಟಿಗೆ ಮೈನಸ್ ಆಫ್ A ಅನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ? ನೆಕ್ಸ್ಟ್ ನೋಡುವ. ಗೊತ್ತಾಯ್ತಲ್ಲ? ನೋಡಿ, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳುವ. A 3 5 7 4 6 8. B 1 0 3 5 9 4. Add them. Add the corresponding entries. So the sum A plus B is given by 3 plus 1, 5 plus 0, 7 plus 3, 4 plus 5, 6 plus 9, 8 plus 4. That is equal to 4, 5, 10, 9, 6 plus 9, 14, 6 plus 9, 14, 8 plus 4, 12. That is something. Sin x plus cos x ಅನ್ನು ಆಡ್ ಮಾಡುದಾ? ಅಲ್ಲ, ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನಾನು sin square x plus cos square x ಅಲ್ಲ ಬರ್ದದ್ದು. sin square x plus cos square x is equal to 1. See, sin x plus cos x ಅಲ್ಲ ಅದು, sin square x plus cos square x. ನೆಕ್ಸ್ಟ್ ನೋಡುವ, ಒಂದ್ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವ. ರೆಡಾ? If nine plus 6, 15. Next, let A equal to matrix 2 4 3, 2. B equal to matrix 1, 3, minus 2, 5. Find A plus B. Try Madi. Find A plus B. Check the order. A is of order 2 by 2. B is of order 2 by 2. So their sum I can add. Detail agi bariಯುವ ಅಗತ್ಯ ಇಲ್ಲ. If possible, add directly. Or else first problem, let me write in detail. So 2 plus 1. Next entry. 4 from the first, 3 from the next. Next entry. 3 from the first, minus 2 from the next. Next entry. 2 from the first, 5 from the next. First two entry with the first entry. Second entry with the second entry. ಅದೇ ಆರ್ಡರ್ ಅಲ್ಲಿ ಬರ್ದ್ರಾಯ್ತು. Yes, very good, very good. Many are giving the answer. 3, 4 plus 3, 7, 3 minus 2, 1, 5 plus 2 is 7. These are the elements of the sum A and B. Another problem. If A equal to A square plus B square, B square plus C square, A square plus C square, A square plus B square. Add this matrix with B equal to 2AB, 2BC, minus 2AC, minus 2AB. Add ಮಾಡಿ ನೋಡ. What will be the sum? A square plus B square plus 2AB. A B square plus C square plus 2BC. A square plus C square minus 2AC. A square plus B square minus 2AB. Add ಮಾಡಿ. ಆಲ್ರೆಡಿ ನಾವು ಆಲ್ಜಿಬ್ರಾದಲ್ಲಿ ಕಲ್ತಿದ್ದೇವೆ ಐಡೆಂಟಿಟೀಸ್. ನೋಡ್ಕೊಳ್ಳಿ. A square plus B square plus 2AB. Algebraic identity. A plus B the whole square. B plus C the whole square. A minus C the whole square. A minus B the whole square. Hope it's clear. Note down ಮಾಡ್ಕೊಳ್ಳಿ ಮಕ್ಕಳೇ. I just applied algebraic identity. Yes, very good, Shambhavi. Yes. ಏನಾದ್ರೂ ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಕೊಳ್ಳಿ. Yes, very good, Ramkrishna, Vamshi, Shambhavi, very good. Yes. Next. Difference of matrices or else subtraction. What if I want to subtract A with B? First, consider matrix B. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಸ್ಕೇಲಾರ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇನೆ. So the next operation is nothing but scalar multiplication. Scalar multiplication. Whenever I consider a matrix A, say Aij, and if I want to identify K into A, matrix obtained by multiplying every entry of A by K, denoted by Kij, is obtained by multiplying every entry of A by K. For example, A equal to 2, 3, 1, 0, minus 4, 5. 3A obtained by multiplying every entry of 3 by A. Sorry, A by 3. 2 into 3, 6. 3 into 3, 9. 3 into 1, 3. 3 into 0, 0. 3 into minus 4, minus 12. 3 into 5, 15. multiplying each and every entry of matrix A by a scalar or a constant. In the particular example, I took it as 3. Multiplying every entry of A by 3. Yes. ಈಗ ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಫಾರ್ ಸಬ್ಟ್ರಾಕ್ಷನ್. ಬಿಫೋರ್ ದಾಟ್ ಇಫ್ ನೀಡೆಡ್, ಈಗ ನಾನು ಎ ಅಂತ ಹೇಳುದನ್ನು 3 -1 -5 0 ತಕೊಂಡ್ರೆ minus a obtained by multiplying every entry of a by -1. 3 into -1 -3, -1 into -1 +1, -5 into -1, 0 into -1. This is matrix minus A. Minus A is obtained by multiplying every entry of A by -1. Next. So now we came across scalar multiplication, multiplying every entry of matrix A by a constant. That constant can be anything. In the first example, I took constant as 3, obtained by multiplying every entry of matrix A by 3. Second example, I just took K as -1, multiplying every entry of A by -1. ಈಗ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿಕೊಂಡು I am going to find what is A minus B. The subtraction. A minus B is defined as A plus of minus B. This is what I had mentioned. Minus B we already know. Multiplying each and every entry of B by -1. Then add with A. Addition already we people came across. Adding corresponding entries of A and B. ಅಷ್ಟೇ ಇರೋದು ಕಾನ್ಸೆಪ್ಟ್. ಗೊತ್ತಾಯ್ತಾ? Example ಬೇಕಿದ್ರೆ again order should be same, then only you can add or subtract. 3 2 0 1 5 minus 1 0 2 minus 4. I am going to subtract. Actually, ನಿಮಗೆ ಆಗುವುದಾದ್ರೆ ಡೈರೆಕ್ಟ್ ಮಾಡಿ. Multiplying the second entry by -1 ಮತ್ತೆ add ಮಾಡುವ ಅಗತ್ಯ ಇಲ್ಲ. You can directly subtract the corresponding entries. So 2 minus 1 1, 0 minus 0 0, 1 minus 2 minus 1, 5 minus -4. ಕೇರ್ಫುಲ್ ಆಗಿ ಮಾಡಿ. ಲಾಸ್ಟ್ ಎಂಟ್ರಿ ಕೆಲವರು ರಾಂಗ್ ಮಾಡಿದ್ರು. ರಾಮಕೃಷ್ಣ, ಲಕ್ಷ್ಮಿ ನೋಡ್ಕೊಳ್ಳಿ. 5 minus -4, 5 plus 4 which is equal to 9. Yes, yes, very good, very good. ಅದು A minus. ಗೊತ್ತಾಯ್ತಲ್ಲ? ಈಗ ಇದೇ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು let us do some problems. ನೋಡ್ಕೊಳ್ಳಿ. Let us do some problems. Take down the question. Simplify. Cos theta into cos theta sin theta entries. Cos theta sin theta minus sin theta cos theta plus sin theta into sin theta minus cos theta sin theta. Find the simplified form. Compare the entries. I actually need to multiply by a scalar. For the first matrix by cos theta, second matrix by sin theta. Then I need to add. Both are of same order, so I can add the matrices. Apply. Simplify. So if I apply scalar multiplication, cos square theta, cos theta sin theta, minus sin theta cos theta into cos theta, cos square theta, plus multiply every entry of the second matrix by sin theta, sin square theta, minus sin theta into cos theta, sin theta into cos theta, sin square theta. Add them. Add the corresponding entries. First entry, cos square theta plus sin square theta. Trigonometric identity gives us 1. Cos theta sin theta plus minus sin theta cos theta. 0. Cancels with each other. Same in the next. Last term again trigonometric identity. Now can you tell me what matrix is this? 1, 0, 0, 1. What kind of matrix is this? Yes, do reply. Yes. Very good. Exactly. Identity matrix of order 2. 1, 0, 0, 1 is an identity matrix of order 2. ಇನ್ನೊಂದು ಕ್ವಶನ್ ಮಾಡ್ಕೊಳ್ವಾ? ರೆಡ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಗೆ ಹೋಗುವ. ನೆಕ್ಸ್ಟ್ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತೂ ಹೇಳ್ಬಹುದು, ಬಟ್ ನಮಗೆ ಅಲ್ಲಿ ಐಡೆಂಟಿಟಿ ಸ್ಪೆಷಲ್ ಕೇಸೇ ಉಂಟಲ್ಲ, ಸೊ ಕನ್ಕ್ಲೂಡ್ as an identity matrix. All diagonal matrix are not identity, but every identity matrix is a diagonal matrix. So better ನಮಗೆ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೊತ್ತಿದ್ದ ಕಾರಣ ಅದನ್ನೇ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಸೊ ರೆಡ್ ಆನ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಫೈಂಡ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ. Find x and y. If 2 into matrix 1, 3, 0, x plus matrix y 0, 1, 2 equal to matrix 5, 6, 1, 8. Find x and y if these two are equal. Left side on the consider ಮಾಡಿ. 2 into something, scalar multiplication, plus another matrix, addition of matrix. Right side ಅಲ್ಲಿ ಏನುಂಟು? Equal to some other matrix. 2 matrices are equal implies corresponding entries are equal. ಅಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ. So what I can write? Left side, take 2 inside, 2 into 3, 6, 0, 2x plus y 0, 1, 2 equal to 5, 6, 1, 8. ಮಾಡಿ ಎಲ್ಲ ಟರ್ಮ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಆಡ್ ಮಾಡಿ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆಯುವ ಅಗತ್ಯ ಇಲ್ಲ, ಬಿಕಾಸ್ ದ ಕ್ವಶನ್ ಇಸ್ ಟು ಫೈಂಡ್ ಎಕ್ಸ್ ಅಂಡ್ ವೈ. 2 matrices are equal implies corresponding entries are equal. X ಇನ್ವಾಲ್ವ್ ಆದ ಟರ್ಮ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ರೆ ಆಯ್ತು. X ಎಲ್ಲುಂಟು? ಲಾಸ್ಟ್ ಎಂಟ್ರಿ. So last entry from the first matrix 2x. I'm adding from the second matrix it is 2, and the last entry of the right hand side 8. Solve for x. 2x is equal to 6. X is equal to 3. Similarly, and L into y, first entry. So 2 from the first plus y from the next, right side only 5. 2 alas. Y, yeah. 2 from the first, y from the next, 5 from the right. Therefore, y is also 3. Clear ಆಯ್ತಾ? ಪುನಃ ಅಲ್ಲಿ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮರೆಯುವ ಅಗತ್ಯ ಇಲ್ಲ, ಡೈರೆಕ್ಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಕನ್ಕ್ಲೂಡ್. ಎಸ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಬರ್ಕೊಳ್ಳಿ. ಫೈಂಡ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಎಕ್ಸ್ ನೌ. ಫೈಂಡ್ ಎಕ್ಸ್ ಎಫ್ y is equal to matrix 3, 2, 1, 4 and 2x plus y is equal to 2x plus y equal to 1, 0, minus 3, 2. Find x. If y equal to 3, 2, 1, 4 and 2x plus y is equal to 1, 0, minus 3, 2. ಹೇಗೆ ಮಾಡಿದ್ರು? Question ಕೇಳಿದ್ವಿ x identify ಮಾಡಲಿಕ್ಕೆ. Already y is given. Make use of that. So 2x plus y. Y is 3, 2, 1, 4 equal to 1, 0, minus 3, 2. Rewrite ಮಾಡಿ. From which I can write 2x is equal to, ಇದನ್ನು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬೇಕು. ಹಾಗೆ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ. ಸಬ್ಟ್ರಾಕ್ಟ್, rearranging 1. Shift this to other side. So when I shift, becomes minus 3, 2, 1, 4. What I'll get? 1 minus 3 minus 2. 0 minus 2 minus 2. Minus 3 minus 1 minus 4. 2 minus 4 minus 2. This is 2x. Therefore, x 1 by 2 times. Multiply every entry of x by 1 by 2. Minus 1, minus 1, minus 2, minus 1. Clear, Allah? Yes, very good, very good. Many are giving the right answer. Exactly. Next. If x into matrix 2, 3 plus y into matrix minus 1, 1 equal to matrix 10, 5. Find x and y. Find x and y. Two matrices are equal implies corresponding entries are equal. Left side we have matrix scalar multiplication and addition. So I'll write 2x minus y equal to 10. ಗೊತ್ತಾಯ್ತಲ್ಲ? Multiplying by x, multiplying by y, adding corresponding entry equal to 10. Similarly, 3x plus y equal to 5. I have two equations into unknown. Solve for x and y. ಯಾವ ಮೆಥಡ್ ಬೇಕಿದ್ರೂ ಆಗ್ಬೋದು. Either elimination or substitution or cross multiplication in order to find x and y. ನಾನು substitution method ಅಲ್ಲ, elimination method is easy. So I'll apply elimination method. If I add 5x is equal to 15 implies x is equal to 3. When x is 3, y is equal to, I'll use the second equation. Y is equal to 5 minus 3 into 3, 9 minus 4. Very good, very good. You already gave the answer. Yes, Subhash, Shambhavi, Uttapa, Nagamani. Very good. Scalar multiplication, addition and equality of two matrices. Concept ಗೊತ್ತಾಯ್ತಲ್ಲ? Very good, very good. Now, let us move to very important concept known as matrix multiplication. Very important. Multiplication of matrices. Okay. Listen carefully. Let me explain in detail. I'll consider matrix A. Let order of A equal to m by n. Consider B. Order of B equal to k by p. I took two matrices of different order. The product AB is defined if number of columns of the first equal to number of rows of the second. If number of columns of the first matrix equal to number of rows of the second matrix, then the matrix multiplication in this order is defined. And order of the product is nothing but the remaining entry in order M by P. A is of order M by N, B is of order K by P. If N and K are equal, number of columns of the first equal to number of rows of the second, then we can find the product, the multiplication, the product AB is defined, and in the case, order of the product is given by M by P. The remaining entries in order. Very good, Ramakrishna. Now, every time AB need not imply BA. Matrix multiplication is non-commutative. ಕೆಲವೊಂದ್ಸಲ ಡಿಫೈನೇ ಆಗಿರೋದಿಲ್ಲ. That and all we'll discuss later. ಈಗ ನಾನು if I consider A of order 2 by 3, B of order 3 by 4, number of columns of the first equal to number of rows of the second, I can find the product, and order of the product matrix is given by 2 by 4. If I consider B or B as of order 1 by 2, C as of order 2 by 5, then order of C is BC is defined by 1 by 5. Clear? ಈಗ ನೋಡಿ ಆರ್ಡರ್ ಆಫ್ ಎ ಬಿ ಇಸ್ 2 by 4. ಅದೇ ನಾನೀಗ ಬಿ ಎ ಮಾಡ್ತಿದ್ರೆ ಆರ್ಡರ್ ಆಫ್ ಬಿ ಎ ಚೆಕ್ ಮಾಡಿ. ಬಿ ಆಫ್ ಆರ್ಡರ್ 3 by 4, ಎ ಆಫ್ ಆರ್ಡರ್ 2 by 3, not defined. I can't find the product B A because number of columns of B not equal to number of rows of the A. Very good, very good. Many are giving the right answer. So, existence of AB need not imply existence of BA. Exist ಆದ್ರೂ ಕೂಡ, for example, if A of order 2 by 3, B of order 3 by 2, both AB and BA are defined, and order of the product AB 2 by 2, order of product BA 3 by 3. ನೋಡಿ ಇಲ್ಲಿ both AB and BA are defined. Previous case ಅಲ್ಲಿ AB defined, BA not defined. ಈಗಿನ ಕೇಸಲ್ಲಿ both AB and BA are defined, but unfortunately order are unequal. Two matrices are equal only if their orders are same, but order of first is 2 by 2, second of order 3 by 3, they are unequal. So AB not equal to BA. Clear? Now, ಈಗ ಇನ್ನು ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ಹೇಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು? A11, A12, A13, A21, A22, A23, order 2 by 3. B, order number of rows should be 3. No restriction about number of columns. I'll take for time being 3 by 2. Say B11, B12, B21, B22, B31, B32. Then the product AB. ಹೇಗೆ product ಇನ elements ಅನ್ನು identify ಮಾಡಿ. Clearly I can say order of AB is equal to 2 by 2. There are 2 rows and 2 columns. ಈಗ identify particular entry of the product. Say for example, general matrix of order 2 by 2 is of the form A11, A12, A21, A22. ಈಗ ನಾನು 1 1 entry ಮಾಡಬೇಕಿದ್ರೆ find the first row from the first matrix, first column from the second matrix, multiply pairwise and add. So I'll write the product now. First row, A11, A12, A13. First column, B11, B21, B31. Multiply pairwise and then add A11 with B11 plus A12 into B21 plus A13 into B31. What about the next entry? Next entry is actually one-tooth entry obtained by considering first row from the first matrix, second column from the second matrix. Yavaglu, yesterday itself I told, first value Yavaglu indicates the row in which entry lie, second indicates always the column in which the entry lie. So naniga A12 identify madidre, first row from the first matrix, second column from the next matrix, multiply pairwise and add them. ಇಲ್ಲ ಸೇಮ್ ಆರ್ಡರ್ ಇದ್ರೂ ಕೂಡ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ನಾನ್ ಕಮ್ಯುಟೇಟಿವ್ ಮತ್ತೆ ತೋರಿಸ್ತೇನೆ ಲೆಟ್ ಇಟ್ ಬಿ ಸೊ ಐ ಮಲ್ಟಿಪ್ಲೈ ನೌ ಫಸ್ಟ್ ರೋ ವಿತ್ ದ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಫಸ್ಟ್ ರೋ ವಿತ್ ದ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಪೇರ್ ವೈಸ್ ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ದೆನ್ ಆಡ್ ಸೊ ಐಲ್ ರೈಟ್ A11 with B12 plus A12 into B22 plus A13 with B13. B31. Sorry, what I wrote? B32. Okay. B32. A11 with B12. A12 with B22. A13 with B32. Next. Second row. Yav entry. Second row. This is actually second row. First column entry of the product. Second row. First column entry. So second row from the first. First column from the second. Multiply pairwise. A21 B11 plus A22 B21 plus A23 B31. First, second row with the first column. Here, next entry is second row, second column. So, I'm going to multiply second row from the first, first column from the second. A21 into B12 plus A22 into B22 plus A23 into B23. A23 into B32. This is the clue. This is how we need to find the product of two matrices or matrix multiplication. Matrix multiplication is defined if number of columns of the first matrix equal to number of rows of the second matrix. And to find the general entry of the product, say if I want to find one-tooth entry, first row, second column entry, consider the first row from the first, second column from the second, multiply pairwise and then add. Clear alla? ಒಂದು example consider ಮಾಡಿ, I'll explain the concept. Example, if I want to multiply 1 minus 2, 2, 3 into 1, 2, 3, 2, 3, 1. First matrix, order 2 by 2. Second matrix, order 2 by 3. Number of rows of the first equal to number of columns of the second. Thus, matrix multiplication is defined. And the order of the product matrix 2 by 3. Clear? Number of rows of the number of columns of the first equal to number of rows of the second. Order of the product matrix is 2 by 3. Now how to find it? 2 by 3 general matrix I'll write over here. A11 A12, A13, A21, A22, A23. I'm going to identify first entry, 1/1 entry obtained by considering first row from the first column from the second, multiply pairwise and then add 1 into 1 plus minus 2 into 2. ಗೊತ್ತಾಯ್ತಾ? ಅದು ಆಕ್ಚುಲಿ ಎಲ್ಲ ಬರೆಯುವ ಅಗತ್ಯ ಇಲ್ಲ, ನೋಡ್ಕೊಳ್ಳಿ. I'll write 1 into 1, 1 plus minus 2 into 2, minus 4. Next, first row with the second column, A1, 2, 3 entry, multiply. First row with second column, 1 into 2 is 2, plus minus 2 into 3, minus 6. Next entry, first row with the third column, 1 into 3 is 3, minus 2 into 1 is minus 2. Next, second row with the first column, 2 into 1 is 2, plus 3 into 2 is 6. Second row with the second column, 2 into 2 is 4, 3 into 3 is 9. Second row with the third column, 2 into 3 is 6, plus 3 into 1 is 3. Simplify, minus 3, minus 4, 1, 8, 13, 9. The product. Many are giving the right answer. Very good. Yes. Hanmantappa, you are right. You are right. Yes. One more example. Matrix 2, 1, 3, 2, minus 1, 1 into matrix 1, 0, 1, minus 1, 2, 1. Multiply ಮಾಡಿ ನೋಡಮ್. Order of the first matrix 3 by 2. Order of the second matrix 2 by 3. Number of columns of the first equal to number of rows of the second. Product exists. Order of the product matrix is 3 by 3. 3 by 3 will consist of 3 rows and 3 columns. Consider 1 by 1. ಬೇಕಿದ್ರೆ ನಾನು ಜನರಲ್ ಆಗಿ ಬರೀತೇನೆ. A11, A12, A13, A21, A22, A23, A31, A32, A33. ಮಾಡಿ ನೋಡ. First one, A11. First row with first column, 2 into 1 is 2, plus 1 into minus 1. Next, first row, second column, 2 into 0, 0, plus 1 into 2 is 2. First row, third column, 2 into 1 is 2, plus 1 into 1 is 1. Very good. Yes, Subhash. Next, second row ಗೆ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇನೆ. Second row, first column, 3 into 1 is 3, plus 2 into minus 1 is minus 2. Second row, second column, 3 into 0, 0, 2 into 2, 4. Add them. Next, second row, third column, 3 into 1 is 3, plus 2 into 1 is 2. Next, third row. Third row from the first and columns 1 by 1 you consider. Minus 1 into 1, minus 1. Plus 1 into minus 1, minus 1. Next. Minus 1 into 0, 0. 1 into 2 is 2. Minus 1 into 1, plus 1 into 1. Minus 1 plus 1. Add them. 1, 2, 3, 1, 4, 5 minus 2, 2, 0. ಗೊತ್ತಾಯ್ತಲ್ಲ? ನೋಡ್ಕೊಳ್ಳಿ. Any doubt? Yes. ನೋಡಲ್ರಿ ಪ್ರಾಬ್ಲಮ್ ಟ್ರೈ ಮಾಡಿ. 1, 2, 3 into 2, 3, 4. ಟ್ರೈ ಮಾಡಿ ನೋಡ. A of order 3 by 1. B of order 1 by 3. Order of the product matrix 3 by 3. ಮಾಡಿ ನೋಡ. 3 rows, 3 column. Very simple. First row with first column. First row with second column. First row with third column. ನೋಡಿ ಚೆಕ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡಿ. ವಿಷ್ಣು, ಭಾವನಾ ಚೆಕ್ ಮಾಡಿ. ಜಾಹ್ನವಿ. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ರೋ. 2 into 2, 4. 2 into 3, 6. 2 into 4, 8. Second row with all the columns. Next, third row. Third row with the first column, 6. Third row with second column, 9. Third row with the last column, 12. Check madi. Many had given different answer. Very good. Ramappa, Ramakrishna, Shobha. Yes, Sunita, Subhash. Very good, very good. Solve the problems. One more problem, let me write. Try by yourself. Matrix 2, 1, 3, 2, minus 1, 1. 1, 0, 1, minus 1, 2, 1. ಮಾಡಿ ನೋಡ. Everyone try this. Try. Let me wait. Give the answer. Yes. Complete ಮಾಡಿ problem. Today's class got over. Let us continue in the next session. Yes. Thank you.